Okay, guys, in this segment, we shall learn how to find the vector equation of the line of intersection of two planes. You see that when two lines intersect, they intersect on a point, okay? So this point over here, we call that this is the point of intersection of these two lines. But when you have two planes, when they intersect on a line. If you look at it in your room, if you see the front wall meeting with the ceiling of your room, so you can see clearly a line between the wall and that ceiling. If you see the two walls on your right meeting at right angle, Hannah, so you see there's clearly a line between these two walls. Okay, so whenever we have, like, for example, if you have here, like, this is here one wall, this is another wall over here. Okay, so if you see that this is these lines over here, uh, okay, so if I talk about this plane here, okay, and then I talk about, I refer to this plane here. So you can see that these two planes are, this is the, let me, this, yeah. So this is the line of intersection of these two planes. If these planes are going up to infinity, so you see that this is the line of intersection of these two planes. Okay, so how to find the line of intersection of this plane? So when you have to learn this, then you should go back to the method where you were writing the equation of a line. When you have to write the equation of a line, the thing is that you must remember that we need to have a point on that line, and then we have to have the direction vector of that line over here. So here is a concept that, if this line, we are going to find the equation of this line, then you must agree with me that the normal to this plane, the normal to this plane, and the normal to this plane, they are both going to be perpendicular to this line. Yes or no? Hmm? Like, the normal to this plane is like this. Okay, it is going to be like this. So this is going to be perpendicular to this line, and the normal to this plane is going to be like this, Hannah. So this is going to be perpendicular to this line as well. Yes or no?
Yes.
Obviously, this line is contained by both the planes. So since normal is perpendicular to the plane, so the normals to both these planes have to be perpendicular to this line. So this problem is going to be solved here, how to find the direction vector of this line. So that would be obtained through the cross product of the normals of these two planes. Okay. So if you have here, like, one of the equation is x plus 3y minus z, that is equal to 1. So you have n1 from here, which is going to be 1, 3 minus 1. Okay? And then you have the second plane, which is going to be 2x plus 4y plus z, that is equal to 6. So your n2 is going to be 2, 4, and 1. So guys, if you perform the cross product of these two direction vectors, you will get the direction vector of the line here. That is going to be 1. Can you please quickly do that and give me that normal here? 2, 4, 1. So this is going to be 3 plus 4, 7.
You just took random equations of planes, right?
No, no, I'm doing this question here.
Okay, okay.
This question here. Okay, now this is going to be now the next one is 1 plus 2, this is minus 3, and then you have 4 minus 6, that is minus 2. So that is the direction vector of this plane, I mean this line. Okay, now we are done with finding the direction vector of the line. Now the problem is how to find a point on this line, which is going to be this A. How to find this A? So you will have to trust me that, guys, if you imagine this line going up to the infinity on both the directions, like if I take you back to the to your two-dimensional thing, if you have a line in general, and let's assume that that is going to be a diagonal line. So when you have a diagonal line, there is this line will definitely pass through the vertical axis, where it will have the point like 0 comma y, okay, and this will be passing through once through the x-axis, and the point over here would be x comma 0. So similarly in 3D, like, if you have, this is your x, this is your y, this is your z, so this line will somewhere pass through the, if this is your o, this is your x, this is your y, and this is your z, it will be like, if you take this to the infinity, so if it passes through the xy plane, so there it will have the coordinates x comma y comma 0. If it passes through the yz plane, there it can have a point over here which is going to be 0 comma y comma z, okay, and if it passes through the xz plane, there it can have a point which is going to be x comma 0 comma z. So the problem is that we are going to assume all these situations here, because we have to solve these two equations simultaneously so that we get a point on this line. So you have to assume any of these three situations here. Some of you might like putting y equal to 0 in both of these equations. Some of you might put x equal to 0, and maybe one of you put this z equal to 0. So all three of you would be correct if you choose any of these options here, okay? So let's put x0 here, or you have to decide by looking at these equations. So I think let's put y, because the y's coefficients are bigger. So I'll be putting y0 here. So when I put y0 here, I'm assuming that this, when this line is going to pass through the xz plane, there the y coordinate would be 0. So this leaves us just with two unknowns into these equations. One is x minus z equal to 1. The other is going to be 2x plus z, that is equal to 6. Let's solve them simultaneously to find the x and z. If I add them, I get 3x equal to 7. So my x coordinate is going to be 7 by 3. I already have my y coordinate, which is 0. This is the x coordinate here. Then you put x into these equations. So you have uh, z is equal to x minus 1. So z is 7 over 3 minus 1. So this is going to be 4 over 3. So this is the z coordinate of that point on this line. So this way we get the equation of the line of intersection of these two planes, which is going to, oh, what was that? Normal to the plane. Did you write that, Bicho? So that is going to be r equal to,
So 7 minus 3 minus 2.
just a minute, let me write this first. 7 over 3, this is 0. We cannot simplify this because it's a position vector, okay? And then plus lambda here. Now tell me, what was that?
7 minus 3 minus 2.
7 minus 3 minus 2. So that is the equation of the line of intersection of these two planes. So let me give you a recap. You will find the direction vector of this line through the cross product of the normals to both the planes. And then you will have to solve the equations of the plane simultaneously to get the position vector of a point on this line. Okay, we are solving these two equations, the equations of planes, because this line is contained by both the planes. So the point has to be on both the planes. Therefore, we solve the equations of the planes simultaneously. While solving these equations simultaneously, we have to reduce these two equations up to two variables. For that purpose, you can either put your x0, you can put your y0, you can put your z0. Okay. So let's see what he has done here. Let me see his answer. Now, our normals are matching 7 minus 3 minus 2. Okay. And then he has, oh, he has put x as 0. No problem. So you see, you can put your x0, you can put your y0. So he has this equation over here. He has a neater equation than us. Anyhow, so he has kept x0. So there are three possible answers, because people can take any of the option of putting 0, this x, y, or z. Anyhow, so this is very much correct. This is 100% correct. The equation the line of intersection of these two planes. Okay. And next, I'll be telling about how to find the angle between two planes.